I guess the Mongo user group is here as well, right?
All right, all yours.
Okay, so tonight we're going to talk about MongoDB Spring Data. I work for a company called ICF Ironworks. It was Ironworks. ICF bought us. A little bit about us really quick. We do a lot of different integrated services. Interactive is where we play most of our time, but we also do portal and content management and then business and strategic consulting. Some of our partnerships, some of the companies that we work with, a lot of them are on the East Coast, which is, in case you wanted to know, about 5.5 hours by flight. Who am I? Solutions architect right now for ICF Ironworks, sometimes a part-time teacher, been in the industry for a little while. Pretty much a fast follower instead of a leader. I like to get out there and let other people do things and stumble, and then I pick up and make it look good. Take the benefit from that. These slides and all my code will be available tonight, so in case you want to look at anything later on, feel free. Some of the things I'm going to go through pretty quickly. Here's what we're going to talk about. NoSQL in general, Mongo database in general. This is not an exhaustive deep dive into Mongo database or replication setup or anything like that. This is basically Java integrated to Mongo Spring Data. Okay. Introduction to Spring Data, what it is, with mostly focusing on templates and repositories with some customization in there as well. And then I'll throw in at the very end some aggregation functions that are part of the Mongo Java API as well as the greater best file storage system. A little information about indexes as well. So I don't think I should have to dive too far into this. What is NoSQL? It's primarily on the East Coast, we call it not only SQL. I'm assuming that that's a fairly, general term. We're looking at it primarily to get rid of the impedance mismatching between our applications and relational databases. Not all relational databases, or not all applications fit relational databases. We're starting to see more solutions for that. Some of the sweet spots are content management nodes inside the content delivery networks. Document-based applications are great for Mongo, that type of thing. But it's different things for different folks. I'm not going to focus too much on it beyond this definition of basically being non-relational, distributed, open source, and horizontally scalable. In some cases, massively horizontally scalable, and in Mongo's instance, almost automatic. We'll talk about sharding and replication. Some of the NoSQL flavors, so I'm not talking about Mongo, but in that same circle, there's Couchbase, which is near and dear to my heart as well, because one of the main developers of Couchbase used to be a Lotus Notes guru, so I'm an old Lotus Notes person myself, which, by the way, as far as I'm concerned, is one of the first NoSQL databases. Some of the other databases, I messed around a little bit with MarkLogic, so that kind of gives you some idea of where some of those databases fly in application spaces. So why do I like Mongo? Well, it's written in C++, so I take it that that is fast. It's optimized. It's really fast, really quick. I like things that are really fast. Oracle's fast too, but MongoDB is fast to get up and running and start using it within an hour instead of weeks. Multiple platforms, explicitly denormalized, so I don't have to try to make my application fit within third normal form. Anybody ever gone beyond third normal form to fourth normal form? Exactly. It's document-centric and schemaless, which means that I can be a complete cowboy in the application layer. So there's more rigor that needs to happen there in the application layer. It's fast, low latency, very memory intensive, but it's, that's where we get the low latency from. Ease of scalability, replication sets, also auto sharding. We'll get into a little bit about sharding and how to set up sharding with keys. Manages complex and polymorphic data. That's because it's underpinned by a binary JSON. We'll get into a little bit later. Some sweet spots. Again, I mentioned CDN, but basically any kind of document-based SOA solution you can throw in Mongo. You can build relational systems in Mongo. It's not the sweet spot as far as our organization is concerned. We already have relational databases for that, but you can do it. great for location-based and geospatial data solutions. As a matter of fact, the company that sort of manages the Mongo code base, 10gen, they have solutions out there for location and geospatial-based solutions. Schemaless means it's more flexible. You can store from one document to the next in the same collection. You can store different data, different field types. It allows an agile team to come up very fast and start using the data store without having that long, drawn-out data modeling and provisional sequence that has to happen with relational databases. If you're a JavaScripter, JSON is really easy to understand, so that makes it that much easier to handle what's going on in the back end. And then 10gen, quite honestly, has been fairly responsive with regards to getting Mongo updated and getting information about Mongo out to the developers. So when I say schemaless, what do I mean? Well, schema-free. 10gen says flexible schema. I think at the very beginning, there was a lot of people saying schema-free, and it scared some folks. Now we're saying flexible schema. But it really is schema-less. It's schema-free. The schema that goes into Mongo database is basically pushed in by the application layer and by the data modeling through the application layer. You can start up Mongo database and immediately start sending data to it. It creates the database on the fly. It creates the collections on the fly, using Spring, that is. It creates everything on the fly for you. There's not anything you got to go in there and do before you start putting data into it, except for security setup and that type of thing. That's why I call it free. They call it flexible. Again, it doesn't enforce column data types. To me, that's what the application steps in and does. That's what the application does. The most important thing here on this slide is the bottom line. It requires more rigor on the application side. We as application developers, let's face it, a lot of times we're known as cowboys when it comes to the relational database folks. The DBAs are always telling us what's your application, it's not the database. With Mongo database, the application side has to have a lot more rigor in what they're doing. And which means, quite honestly, we have to have maybe a stronger database administrator that kind of straddles the database and the application, understands what's going on there between the API and the database. Because Mongo will let you do some crazy things. Okay. So a little bit of information about data modeling. I'm not going to go in depth with data modeling. But if you look at some of the things you would do inside Mongo database, you have to consider some of the things as far as document embedding, which is fastest and it's atomic. Mongo supports atomicity at the document level. And that'll mean more to you when I get into referencing. But you can think of it, if I have a document or if I have a data set inside my application that says essentially is an employee, and then the employee belongs to departments. So I've got an employee object and a department object, and they're related to each other inside the API, inside the object space. I can embed that department information inside the employee document. So that's not normalized. So if I had 300,000 employee documents, each with their own embedded department in there, you can imagine if the department changed, how many documents am I touching? 300,000. So it's not probably the best solution for that type of relational need. However, it is the fastest and the atomic solution when you embed those documents. If you need a more relational data model inside Mongo, then you would use what's called references, which essentially creates a reference from one document to the next. So I would reference the department inside the employee document. That way I could just touch the department without having to touch the employee document. So there's trade-offs, obviously, making those decisions. Data durability, not necessarily available in a single server setup, needs sharding and or replicas, that type of thing. If you're looking for patterns and data modeling information, there's a link on the 10gen site, and it actually has some videos that came out last year, mid to late last year, that talked about data modeling. So why not Mongo database? Now this is at ICF Ironworks, this is our look at why we would not use Mongo database. Now I understand that this may collide with someone's impression here. But for banking and high-speed accounting type applications, transactional apps, this is not what Mongo would, it's not a sweet spot for Mongo. Okay, I mean, there are patterns that you can put in place for Mongo database to use, multi-phase commit type patterns, but I would not choose Mongo for this. If you absolutely have to have SQL, which I had never absolutely had to have SQL or absolutely wanted SQL, but there it is. If you need joins, Mongo doesn't support joins. Not SQL joins, that is. Traditional non-real-time data warehousing operations. If we need to do data at rest, data warehousing, and aggregation and analytics on huge data sets, we generally will not build those inside Mongo. The last one is most important. If you lack the rigor in your application development space to manage a schema and push it out to the database, knowing that your APIs can go out there and pollute that database, then Mongo is probably not a good tool for you until you develop that rigor. Because it can be costly. Yeah.
Can you be more specific about what kind of rigor you're talking about?
When I say rigor, I mean, if you were to build an application with a relational database, and the DBA built your data model for you, and they use referential integrity between all the, the related tables, primary key, foreign key relationships. Maybe they turned on cascaded deletes for you and all that. You are forced to push data into, pull data out of, delete data, whatever, based on what that data model is set up inside that schema. Say it's an Oracle database. Inside that schema with referential integrity, you're forced, as an application developer, to use a contract, let's say, that the DBA put in place. That contract, for the most part, is missing in Mongo. So being forced into a contract really is up the chain a little bit more and inside the Java API. At least that's been our experience today. So that's when I say rigor.
Are you saying that we need to have our own rigor and our own?
When I say rigor, I mean the application developers and architects have to develop the data model and the persistence layer such that it manages that schema, which is more or less an abstract schema and not a physical schema managed at the database level, for the most part. So Mongo was, as far as we're concerned, Mongo was designed to overcome some of the performance.
Another question.
Yeah.
Question.
Yeah.
You didn't mention here, I'm wondering if they fixed that. One big reason for not using MongoDB was that their MapReduce separation sucks big time. It's very, very slow, single threaded. Did they fix that, or it's still the case?
Well, that's a good question, and I don't know the answer to it. I'm running 1.8.6, I think, 64-bit for the Windows. I'm not running 2 yet. They've made some upgrades in 2, but I really have not been able to test it yet. So their MapReduce is very memory intensive, very costly.
Very slow.
Yeah, so we haven't, quite honestly, we don't use a lot of MapReduce on Mongo yet. We primarily focus more on, for MapReduce, we would be using larger data sets, and so we would be looking primarily at something like Cassandra. Mongo will support, Humongous Database, that's where the name comes from, Mongo, but we're just not there yet. So.
MapReduce internal to Mongo, or is this an external program?
It's external.
It's external, but there's APIs that allow you to do
JavaScript and
certain
a
aggregations.
single one, and single thread.
But there are users with a MapReduce system, aren't there?
Not
Good thought.
Okay, so some of the features, it's fast querying, atomic operations, again, pay attention to embedding your documents as opposed to linking them, and then you get more atomic operations. In place updates. Mongo likes to do a lot of things in memory before it physically writes it to the disk. So this is sort of like, I guess, the redo log or whatever it is in Oracle, but not 100% the same. Full index support, including compound indexes. You can also index on arrays, that type of thing. Replication, high availability. We'll talk a little bit about the CAP theorem in here in a few minutes. Auto sharding, so on. In-place updates, physical disk writes and lags and memory changes, multiple writes. So you can expect that if you're doing a lot of writes to records inside or documents inside MongoDB, you could see I don't know, hundreds of writes to the same document before Mongo decides to put it to physical disk. I mean, it's up to the algorithm and the tuning that you've done inside MongoDB. Mongo also uses what's called an adaptive allocation algorithm. It basically looks at how big the document is and how much you are updating it. Because you can imagine, as that document grows beyond its allocation space, it gets a little expensive to move it to another memory space. It has a larger allocation. So Mongo looks at the collections and the documents within the collections, and it basically pads that allocation for that document so that you don't run out of space as quickly as you would normally if you just had allocation just for the size of the document that it is now. So it uses an algorithm to do that. Sharding. So sharding is basically where I decide that I'm going to, and it's different from replication, right? Sharding is where I decide that I'm going to put one set of data over here, and then a different set of data over here. They may have, common look and feel and a common schema, but they are different data. Like geographical data may be for a content delivery network. I may have shards of data over here on the East Coast, shards of data in the central United States, and then shards of data over on the West Coast. I mean, that's just one example of why I would shard. If I have data that's not needed in another node, I would shard it that way. When I start to talk about sharding, you need to understand how Mongo looks at cardinality. So you have to build your sharding and your cardinality such that it's easily divisible. For instance, if I say I'm going to shard on a state field, then everything in that shard must reside in that same state field. So maybe state is not a high cardinality, not a good field to use. But if you looked at, like phone might be a better field, more unique, and easily divisible. Okay, I don't mean that, let's say the domain of states is 50 states, so what I'm talking about is not just a lot of values within that domain, but taking a particular value and easily divide it and subdivide it. That's where sharding really comes in handy. And when you can take your key and easily divide it down, then your auto sharding and your sharding in general is easy to do.
Can I ask a question about that?
Yeah.
Are you saying that if you pick state may divide into 50, but it can't subdivide further than that? Plus, it's not always going to be a uniform thing, whereas with a telephone number, perhaps you can get more uniform.
You can subdivide the telephone number down to area code and down to extension, that type of thing. This slide here talks about what some examples you would choose. State is considered primarily a low cardinality, and the reason they're using geographical information here because of Mongo's sweet spot in the geospatial world. Zip code is potentially low or high depending on the population within that zip code. All right, so there's a risk there. Phone number is generally a high cardinality. When you say high cardinality, it means that more easily divisible, which makes it easy to spread shards across multiple nodes.
But how do you get your shards on the phone number to cluster so they're meaningful? Because the phone numbers have become over time almost, the MBAs have become almost meaningful.
Yes, I don't know the answer to that exactly.
I was just thinking all the splits that have happened over the years, over the last 5-10 years in LA alone.
How about congressional districts?
I mean, these are just examples, of what I mean by cardinality.
I was just wondering if I was misunderstanding sharding.
No, I think you understand it correctly. I think you understand that it could have its own woes if we keep changing those keys and the domain of values within those keys.
Okay.
So I want high cardinality. It's a good start, but if I want sharding to be really worthwhile, I want it to work, then I have to understand that high cardinality does not guarantee query isolation. So I need to look at my indexes, I need to look at my document structures, am I embedding, am I referencing? I also need to look at how I'm tuning Mongo for write scaling. How many replicas do I have set up? And how many, within those replicas, how many sharded nodes do I have? So it can get really, I'd say ugly. It can get really pretty later on. MD5, they say down here. Computed MD5 key. Maybe that's what you use for sharding. that's a little extreme, but any talk that you go to about NoSQL, most of the time will have a talk, a slide about cap theorem. Cap theorem basically states that you can have 2 of the 3, consistency, availability, or partition tolerance. That's not necessarily 100% true anymore. If you look at these very large multi-tenant environments, you can really get if you strive for consistency and availability and you think that you're going to suffer on partition tolerance, with high availability multi-tenant environments, you can actually get really close to for that 100% partition tolerance. So, but if we were to stick by the cap theorem, you could have 2 of the 3. So consistency, obviously, all the nodes, let's say, in a replica set have the same data. So, that may not be all that important, depending on what you're doing. A content delivery network, maybe consistency can lag until it replicates over. Availability, of course, I want it to be there, not only up, but I also want it to respond within normal ranges when I hit it at all times, even high times, right? Partition tolerance is basically network partition tolerance. If part of my network goes down, or part of my nodes within my replica set goes down, I want to be able to tolerate that network outage. Again, with the cloud implementations and multi-tenant implementations, I think we're getting really close to having all 3. Maybe not 100%. Okay, so relational database versus Mongo. Well, relational database has schemas. Mongo does not. Mongo has collections. Schemas that have tables, that have rows, and then you can do joins, you can do group bys, you can do more ACID type operations. In Mongo, you have collections that contain documents. And those documents contain fields. There are no joins. You're not going to do an inner or an outer join inside Mongo database. You can do queries inside the Mongo API that reference documents via the reference IDs that are in the other documents. And we're talking about database referencing here. It's called linking as opposed to nested documents, which is called embedding. I gave you an example of that earlier. So Mongo database collections, they are schemaless. Did I beat that home yet? You can have up to 24,000 collections according to 10gen. They're very cheap to resource. You can have documents of varying shapes and sizes inside them. It really is up to you what you're going to store in there. Basically, collections are considered namespace objects. They're sort of like indexes, they're both namespace objects. They can be nested up to 100 levels as of version 2.2. God help you if that's what you're into, because that's going to be really tight. They can be capped, meaning they can have a limited size. So right there you think of, well, what would I need? It would be capped at a limited size and maybe rotate. Logs, rotate logs. Logs are generally document-based events. So there's a sweet spot right there. As a matter of fact, the op log, which is the operations log inside Mongo database, is a capped collection. So it's, Mongo's eating some dog food there. Mongo documents are JSON. Actually, they're BSON, binary JSON. But JSON is what you see if you're to go in there and look at some of the tools and pull the documents out. Name value pairs basically is what you see in JSON. If you're familiar with JSON, then you know what name value pair basically is there. 16 megabytes maximum size. That only means that that particular document is that size. You can store files that are much bigger than that inside Mongo database. It just uses a grid approach to do that. What you see is what is stored. There are no default fields save one. And that is the ID field, the object ID. We'll get into that in a few minutes. Here's what it looks like. This is a JSON document. For you JavaScript developers, this should be second nature to you, for your Mongo group out there. This is essentially an employee document with an embedded address document and an embedded department document. So this is completely denormalized data. Okay.
And
the ISO date is part of the data types that come with BSON, the binary implementation of JSON, along with compression as well. The object ID is the required field for a document inside a collection, inside Mongo. It's the only field that's essentially required. And then this one here, by default, I leave the class in there and it links it back to employee, but I really don't need that in there. I just left it in there as part of the default API implementation.
So it'd be something like that if it links back to a department, in the department, rather than having the department.
Yeah. Please keep in mind that, you know, I have an employee repository in my API that did that for me, but I could munge that employee document all day long or remove that class altogether, and it doesn't change the way that it interacts with the API. That's just one of the default things that it puts in there unless I turn that off in the configuration. Okay. One thing to point out here, this is the object ID here in the underscore ID field. It is generated obviously by the Mongo database when I store it. However, I don't have to do that. As you see down here in the one per department, I just stuck a number in there. So it's supposed to be unique. So that's about the only thing that you have to pay attention to. If you let Mongo build it for you, it's going to be unique. If you build it yourself, then you have to pay attention to your domain of values and are they going to be unique.
So you said it stores key value pairs. Are we looking at key value pairs there?
We're looking at key value pairs. So ID is the key, this is the value, class is the key, this is the value, address is the key, this object is the value, then within that object you've got address line and so on. So within an object it's key value, within a document it's key value pair.
So city, raccoon city is key value pair within a.
City is the key, raccoon city is the value.
Okay, so it's just nested layers of key value
Yeah.
tables.
Everything with a colon there means you're separating your key and your value.
Right, okay.
And that's a document, so that's a subdocument, right?
That's an embedded document.
Embedded document.
Basically, that's JSON right there. I mean, that's JavaScript documentation. That's,
And that's where you said you can go up to 100 levels deep if you wanted to.
yeah.
And 16 megabytes.
Up to 16 megabytes, 100 level.
Right.
Yeah, you can.
That's nice.
You'll get closer to the 16 megabytes hopefully than you will the 100 levels. You know, don't call me if you do that. All right, so what is BSON? So it's a binary JSON. It adds data types that we didn't have before. It's optimized for performance. It also adds compression. Mongo database install. How do I install Mongo database? Well, for this demo, I installed it like I install Java. I just put it on my hard drive and unzip it, and it's ready to go. And I built a configuration file. You don't have to, but I'll show you that in a minute. If you build a configuration file, there's multiple things you put in there. I have no security set up on my database tonight, so you won't see any security in my configuration file. I did set up the DB path, as well as I've got the RESTful interface turned on, which gives me a nice little web interface to go out there and do some commands on the web against a running Mongo daemon. Okay. MongoD is basically the server, the daemon process. Mongo.exe in Windows, that's the shell, sort of like SQL Plus for you Oracle developers out there. And then I'm using MongoVIEW, which I think at the time that I purchased a license, it was like $45. It's a GUI on top of Mongo shell. The interesting thing about MongoVIEW is it lets you run commands and it shows you what the Mongo shell command would look like. So this is a configuration file that I'm running. Essentially, it just says, here's the DB path, and then turn on rest. And then I use a batch file to run the daemon and say, here's my config file. So Mongo shell, like I said, SQL Plus. MongoVIEW lets you run Mongo shell commands in a GUI format. You can learn the shell commands quickly with MongoVIEW. This is a shell command. Go out there and find a employee record, an employee document basically. Database.employee, which is the collection, find the document within that collection where last name is Smith, first name is John, and then only bring me back the first 50. Okay? And there's another command there called show collections, which enumerates the collections you have in your Mongo database. calls for a demo here, so let me go and, where's Mongo? So here's my Mongo bin directory. Here's my startup at. I'm sorry, it's really small, but essentially it is call the Mongo exe, pass in the config file that I built, and then the config file is essentially the same one I just showed you on the slide. So if I run, Mongo's going to come up and it's telling me that it's waiting for a connection on 27017, and then the web server is waiting for a connection on 28017. So we're ready to connect to it now. And if I look at MongoVIEW, I'll launch MongoVIEW.
So does the data live on your PC, or does it live on some network that you're talking to?
No, this is all on my PC. Obviously, Mongo, in a full-blown implementation, you would have it out on, a replica, a cluster of replicas, Mongo nodes, just like you'd have, say an Oracle rack system or something like that, remote server.
So is there, I presume there's scripts that install there on the whole cluster?
Yeah, I mean, there's installation procedures to do that, yeah. You add a new node to the replica. One of the things you'll see if I were to show you the web server, is that when I bring the web server up, it shows you that this particular node is not part of any replica set. So when you install your nodes, you actually need to say, I want to belong to this replica set, and you'll go out there and discover that. So I'm going to connect to my local database, and I don't think I have anything in it right now. No, there's nothing in it. But that's MongoVIEW. Give you an idea of some of the things I did over here. It shows up down here in the shell. They actually call it learn shell. Database, db.current auth, db.server status. Okay. We talked a little bit about this. This is the web admin interface. You can run some commands. There's a lot more commands when you do belong to a replica set. And there's also another GUI out there called Sleepy Mongoose. I don't know where to come up with that name. I think it's a Python-based GUI. I haven't used it yet. Here is a screenshot of what the web interface looks like, and it tells you some information about your server when it comes up. We're not part of any replication or any replica set, so you're not going to see anything on there. If you were to click on list all commands, it'll list all the commands you can do from this web server. Not all of them will be active. Some of them you can actually click on and do things. The web interface is very limited, especially when you're not using a replica cluster. Okay, so we beat Mongo to death at this point. We've got the server up and running, and now we want to talk to it with our Java API. So in the past, I've also worked with Django and Morphia are the other APIs that I've worked with MongoDB, but I like Spring Data a whole lot more. I'm assuming everyone is familiar with a little bit with Spring at least. If you've not used Spring, then you really need to take a look at it. Not just Spring Data, but Spring in general. So Spring Data is a very large project within the Spring community. It's got a category of sub-projects, one of which is Mongo. And it's supposed to provide a more consistent interface across multiple database platforms. We use it for Mongo. We also use it for JPA and a relational database layer. Like Spring, everything is Pojo-based. Like Spring, nowadays you can use class-based or XML-based configuration. You can get at the low-level API in Mongo if you want to within Spring, and sometimes, in my demos you'll see that I do. It, just like JPA, it provides metadata mapping so that you can map your domain model objects directly to what it would be inside the database. Again, you can get down in the bowels of the API if you choose to hang out there. So the first concept of Spring Data is templates. So Spring Data has multiple layers of abstraction. Templates being one of the lower levels of abstraction. So it's templates set just above the Mongo Java API. And they define an object called the Mongo operation. You define that in your Spring configuration. Once you have that object, then you can run template operations against it. You can reach into that Mongo object or Mongo operations object to go into the lower level API. And then you can use that Mongo object as the substrate when you go into your upper level abstraction, which is the repositories, which is my favorite part of Spring Data. So, I'll go into demo number 1 here, which actually demo number 2, I guess, but this is the first Spring Data demo. So what I have here is a Mongo template test, and I apologize again for the size of the screen. Those of you who may not be able to see the code, it's there really, it's just hard to see. The first thing I do is I do an API, it's a JUnit, all my stuff is JUnit test, so an API for, right, run it before every test that gets implemented. And I'm just setting up my Spring context, and then I'm going out there and saying, give me my Mongo operations object, set that up so that I can reuse it. And then my tests, I'm creating some employee documents, and then I'm saving them using a Mongo ops.save. Boom, they're saved to the Mongo database. Now, we looked at the Mongo database already, and there was no schema, there was no collection, it was just bare. When I run this the first time, actually, before I even put any data in the database, as soon as Spring boots up and connects to the Mongo database, it's going to look at the rest of Spring's configuration, and it's going to see other Mongo repositories that are set up, and it's going to start building out those objects within the database, those collections, I should say. So if I run this, essentially, it's going to go out there and create an employee, then it's going to go query. And this query basically is, using criteria object that uses what we call a fluent API, okay, which is one of the ways that we're writing APIs nowadays. You're writing them fluently so that you can build an object and then use dot notation immediately in line with that object creation to make operations on that object. So it takes a little bit more thinking when you're building a fluent API, but it makes it easier for your developers later on. So let's go ahead and run this bad boy, see what happens. It's really exciting. Oh, it passed. So what did it do for me? Well, I go out to the Mongo database.
Do
I
we
should
cheer
have-
at this point?
What's that?
Do we cheer at this point?
Yeah, you can cheer if you want.
Can we see it again?
No,
I want to see it again.
Yeah, actually, I would be curious.
Clears out the employee between those 2 runs.
I do in my demo script here. I do clear out the database. So what did it do for me? Well, like I said, it went out there and created an employees collection for me, and then created some indexes for me. And if I go out there and look at my employees, I have one document that I created. And I've got the object ID here, the class here that you saw in that screenshot. And then I got some salary information, which is about what I make actually. And then last name and first name. So even though my employee, go ahead.
So what decided what to make indexes on?
The employee domain object, which I haven't shown you yet. Okay. But in the employee domain object, I've got metadata mapping that says, hey, for this field here, make an index. Okay. So essentially, all that test did was go out there and basically create an employee object and then query it back and read it back into the console for us. And then there's other code that I've commented out that basically removes it. Again, the slides and all the code are going to be posted later on, so it's all yours. Do whatever you want with it. Just don't talk bad about me in front of me, please. Okay, so next I want to go clear the database. So I'll just go out there and drop that database. Now that database is clear. Then I'm going to go ahead and run my employee loader. Now the employee loader is going to take a little while to run. And it loads like 300,000 records. So,
How long does it? No.
what's that?
How long does it take?
Like 3 or 4 minutes.
Are you gonna show us employee?
Well, I can show you what it's doing in the database.
Put that employee metadata.
Oh, yeah, I can show you that. I'm gonna show it later.
Yeah, that's what I meant.
I can show it right
Is
now.
it kind of like Hibernate from JPA?
It's very similar. Document collection is employees, so I'm saying every employee document, any object that I store into the database with this back-ended class will be in the employee's collection. My ID field is going to be stored here. I have a private address here. If I were going to database reference it, instead of embedding it, I would put a DB-ref annotation there, but I'm not. I'll show you that in a little bit. I'm indexing this field, employee ID. I'm making it sparse and I'm making it unique. So obviously we know what unique is. Sparse means that if I do not have any data in that particular field, I do not include that document in the index. So it's a way of performance tuning your index. So the data loading is complete. That wasn't that bad. And I have my employees collection. Oh, I actually have customers and everything else. That's because in this particular Spring configuration, I had all my repositories configured there, and it built all the collections for them, even though I didn't put any data into the database for those other ones. So employees actually has 300,000, you can see that there, 300,000 records there. And here's what an employee document looks like. Same as what you saw on the slide earlier. Address, department are embedded documents. Again, the trade-off here is this is completely denormalized. So if you need to change department in 300,000 records, have at it. So you have to go out there and touch 300,000 records.
Question.
Yes.
So how would you do the audit of that? Let's say we have 300,000 records created for the employees, and now we are updating name of the department. Instead of HR, it is something, people relationship, something. Now, we need to update 300,000 documents.
And you want to audit that.
Yeah.
So you're not, what's that?
And transact it.
Well, you want to transact it as well, right? So again, you can do the transactions through using, you have to build it in Java API, following the multi-phase commit, two-phase commit pattern. But again, that's work on your side. It's not built into at least this version of Mongo. The auditing capability as well, you're not going to see, you don't have triggers per se. I would be looking at probably doing it with aspect-oriented, interceptors or something for auditing of every time you're touching the
But that's the job I'm sending to Mongo. I'm not going to retrieve all those employees and update that this way. It would be horrible.
Well, then, I'm talking strictly on the Java API side. You can do it through the script, through the Mongo shell if you want to.
No, it's not a Mongo shell. Through Java API, it's possible to send a task.
But you're going to touch every object when you do so.
Yes, but that will happen inside of the Mongo.
It'll happen in the Java API.
Yeah.
It's the trade-off for having a massively horizontally scalable, because it's kind of like there's one column, the ID, and the other column is just one big string. So every record is just that one.
Yeah.
And so that way there's create and report are cheap, but update and delete are expensive.
Mongo works this way. I send the task, go update this field in this objects, and I can use dot notation. And we'll go out and work on that. And we'll perform the separation. I don't have to retrieve a single object to do that.
Each doc, I don't.
It's like SQL. You send the SQL to the database, and the database works. Mongo works the same way. It has commands. So my command will be go update name on the, it will be a employee dot.
So then you would
department
want
dot
to,
name.
you would basically reach down into the Java API below the template level to do what you're talking about. Yeah.
But how about audit?
Pardon me?
How about audit for that?
I have coding later on for reaching below the template level, yeah, but not particularly for what you're talking about.
But if we doing some, serious system, we usually need to store the records, who
Well, if you're
updated
going
what,
to do,
when.
specifically if you're going to do some transactional and auditing on top of that transaction, then I would suggest, yeah, for speed purposes, for performance, you would go below perhaps the template level and into the Java API, once you're familiar with it. But yeah, I mean,
But I have kind of a philosophical question. So in a relational database, there will be a one single update to department. So I'm updating the department record.
yeah.
But here, even
Only if you
logically I'm
model it.
updating the department record, I have to update
No,
thousands of.
only if you
employees.
model it, only if you model it this way.
Yes, when I model that this way.
If you had the need to update departments in a relational, more normalized manner, you wouldn't embed. You would use database references. The trade-off there would be that you would not have the atomicity when it comes to your querying and your writing, but you would get that more normalized fashion. So you could update one department and have it affect 200,000 records that reference it.
So with a database reference, then it's kind of like a pointer, basically. It's kind of like a
Database
formula.
reference basically is right here. If I had a database reference, what I have here is a link using the ID of the document that I'm referencing to. It would be here. In that case,
Orange.
it's not necessarily a join, but it's the closest thing to it
Right.
that Mongo would support, and then you would pull those documents out. If you wanted to pull the data join like that, you'd pull it via the reference. The issue there is that for database references, you have to, what you didn't notice here was I'm using a repository to push all this stuff out into the database, and I'm going out there and just filling out the documents. I'm saying save the employee, and it's doing all the saves all at once as an embedded document. If I had database references, you can imagine, I have to save the reference document first, and then come back and reference it in the saved employee document.
Spring stuff can't do that for you.
I haven't come up with a way to do it yet in Spring.
I guess you can use criteria query for that.
Pardon me?
Criteria query?
Yeah, you could use a criteria query for that type of thing, but I haven't come up with a way to create the document and automatically, I mean, I would have to put maybe another layer of abstraction on it.
When you pull the employee object back, if it was linked, would the department be there also, or would you have to then go get the department yourself?
No, it'd be there, it'd come with it.
Okay.
Once it's in the API, I mean, once the API knows, when you go into, I'll show it to you right here. When you go into a domain document, a domain model object, like customer has a customer address, but you can see there, it uses an @ddref annotation, which means that I'm not storing the address here as an embedded document, I'm storing just an ID. However, when I go out and retrieve this document, the object graph inside the Java API will contain what you would expect.
Okay.
The Mongo API and the Spring Data API extract that for you.
But that's an N+1 cost.
Well, yeah, it is. I mean, so there's your trade-off, speed versus normalization.
We were talking about sharding earlier, so if I'm using a database reference, how would I maintain locality that or across those?
Ooh, I have to think about that.
You could do it at design time, right? I mean, you could design.
Yeah, I mean, our implementations right now are primarily embedded documents for sharding, but, I mean, I don't see why you could not do sharding. But your reference documents would have to be obviously on the same shard. You wouldn't be able to.
We'll just slow it. Just access by key.
Well, I mean, think about sharding, what are you trying to do? You're trying to increase performance.
Right.
So if you split your database references, split your references across multiple shards,
But
you're not helping yourself.
the department is a low volume thing, which usually the things you reference are lower volume than the referencing things. You're okay with them being on.
Again, I go to a trade-off here. You're talking about normalization versus performance. Whereas in Oracle, normalization gets you transactional performance. That's not what we're talking about here. Wow, okay.
So, when you talk about capture and consistency, how does sharding come into play with consistency? Does it-
Sharding is not necessarily a consistency thing, replication is the consistency.
Right,
Sharding is a performance thing.
right, but you're talking about sharding as almost like a data isolation.
Well, sharding it's a performance thing, and it is a data
Right,
isolation,
I
it's a
understand
query
the intent of
isolation.
it, but after a while, it's gonna dissipate and get.
It depends on the keys you use and the cardinality you use and the sharding setup that you use. I mean, you have control over the sharding and coercing it into the single shard nodes that you want.
So that's not any count.
Your shards could be a cluster of replicas. So you could have this one replica over here that handles this sharded data, and a different replica set over here that handles this sharded data.
Right, is there a counterbalance that you're looking for between the amount of sharding and the amount of consistency you're looking for?
It really depends on the application that you have, I guess. I mean, like I said earlier, in a content that, well, let's put it this way. Your customers are never gonna wanna hear your data is inconsistent across multiple nodes. However, let's say in a content delivery network, maybe consistency lags within multiple seconds or
Facebook.
at the most a minute.
Right, Facebook, Twitter, I mean,
Yeah.
those are not like, you don't need immediate, notifications.
Again, if you're
right
like
away.
Facebook or Twitter or Google and you throw massive amounts of hardware at it, you're gonna get close to all three of those. You're not gonna have an issue. So,
What you're going to do would be addressing ethnicity and the lost update problem.
I'm not getting into that, no, I'm not. That's a little bit in the weeds. I'm primarily focused on Spring Data integration at this point.
Spring Data and Mongo support the notion of, well, I think you already answered that question. It does support the notion of on-task.
Atomicity?
Thank you.
You're not
And
getting-
transactions? I see.
Mongo supports the idea of atomicity, but again, according to the Mongo documentation, in our experience, it has been that if you start to go to database references as opposed to embedded documents, then your atomicity is not guaranteed. It's an atomicity at a document level, that's the guarantee. You can abstract that and, you can have an atomicity at a higher abstraction layer, but you're not gonna have the same atomicity that you talk about at the database layer that you had if you had embedded documents or a single document.
So I understand that atomicity is about replacing it as a commented, but it doesn't indicate that, how do you address the issue of the overwrite problem? I updated something that I was updating stale data.
Yeah. Mongo addresses that through its write tuning. Like I talked about it earlier, where Mongo is very memory intensive. Keeps a lot of things in its operation log before it writes to disk. So that being said, you have less of a chance for stale data, depending on how you have it tuned. Nothing's written to disk yet. So now there's a trade-off there with the tuning as well. You can have it set for tuned for writing as opposed to reading. And again, that would probably be a node by node setup as well. I mean, I can't answer, all your Mongo woes, but
But the question is does the object update support the idea of a reference field as part of the update?
Yes,
yes, it does, especially if you go down
Below.
to the lower level API, the criteria-based query, yes.
so that brings an interesting related question. So if I want to update this through SpringData, that means I retrieve it, change a couple of fields, and save it.
Mhm.
So when SpringData does, is it smart enough to update just the fields I've updated? So they might be a concurrent update to a different field. Okay, so what will happen?
That's something I just don't know. I haven't looked at that at all.
Because when I worked with Mongo and I did just basically update commands, I know they work, they will not touch.
They are
other fields.
independent of the rest of the
But how
document, you're
about
right.
SpringData?
Spring Data, I just don't know. That's not something that, we concentrate on the abstraction of Spring Data because it allows our developers to more quickly develop the applications and, to build them out. We don't have a performance issue, so we really haven't gone into that layer to see what Spring Data is doing underneath the covers.
Yeah, that just seems the price you pay, or what you gain for not having referential integrity or these other protections against data corruption is the performance gain from the.
And I don't mean to sell Mongo short. I mean, I am by no stretch of the imagination am I a MongoDB. You know, I am primarily an application architect using.
Yeah, that's application question, you know. So if I do this update for a single field, I know it will not affect any other updates that
If
might
you're
happen
using
to
the
this.
lower level API, yes.
But, you know,
can't
Hibernate is
guarantee
smart
it.
enough to update only fields I've changed. How about SpringData?
That seems like a great question.
Sounds like you probably want to just write a JUnit test or something and see what, you know,
Yeah.
the
I'm
implementation actually
lazy,
does.
I'm here to ask a question.
All right, yes.
All right, one easy question. Is there a difference in performance from, like, if you've got the embedded documents where you've got employee, department, and say department has work location, which has address, and you need to do a find on address, is there a difference in performance? Especially as these things get to like 16 meg. Is there a difference in performance of having these big documents as opposed to breaking it out and having, you know, a separate location? Even if you
Well,
had-
you know, so the performance comes down to how you tune how you tune the database, you know, and also how you're able to isolate your queries, okay? But for the most part, my experience has been that embedding your documents allows, and it also depends on indexing as well, how your indexes are set up, all right? My experience has been with embedding, it is faster to bring back the document collection or the link to documents in a nested Java object than it is if I'm doing it through a reference API, a DB reference. So there's a little trade-off in my experience that, you know, if I'm using DB references, I'm doing it because I need that normalization, but I don't get the same performance. Now that is, on my machine, is negligible. And I would assume on very large implementations, negligible. But then again, if they're being, very large implementations being hit by very large collections of customers, maybe not so much. I mean, it's a hard question for me to answer. My personal experience is an embedded document is faster to get to than, and the indexes. If you have the right indexes in place, obviously it's faster. But you pay a price with the indexes. The more indexes you have, even the slower your writes are going to be. When Mongo finally does decide to write, it's going to be slower than without indexes. So, the trade-off. Okay, wow, I'm not sure where I'm at now. Okay, employee service test. I feel like I've just been ambushed a little bit. Okay, employee service test. So all these are JUnit, like I said, JUnit tests before. This one just goes out there, sets up my Spring context again, gets a hold of my service. The way that I built my application, my sample application here, and let me start off by saying that this is an employee database, not something that we personally would build inside Mongo because of the need for all the normalization you generally have in an employee database. But I put it in here purposely to show you a normally SQL-driven relational database solution and what it would look like inside Mongo. This is not normally what I would put inside Mongo database. But I built my application such that the calls to work on the employee object is all done through a services layer, my employee service. My employee service just reaches out to the repository. This basically gets a hold of all my employees by last name Smith, do a couple assertions on those, last name Baby, I should have 197 of those. You know, for interest, we're kind of running out of time, so for interest of time, I'm going to have to skip this particular demo, but basically all my tests are set up to run against the data set and return a set of assertions. So if you've got any questions, you can go ahead and email me once you see this code. Okay. So templates. We started off with templates. Again, templates are just above the Java API, of Mongo. They underpin repositories. Here's a configuration inside of Mongo config.xml. It can be very similar to what you're used to in any other Spring application. We're setting up a default bean here of Mongo, listing on the default port. And then we set up a bean ID called Mongo template. And we pass into it the Mongo instance, as well as the database name we want to create when we start to work, and it's our HR database. This is what builds the database when Spring boots up before you put any documents in there. Or config class. Now this config class here, this is actually an application context call that creates a configuration using the Spring Mongo config class that I have. And it gets the Mongo ops operations object, which is again the underpinning of all the template operations you can do. Here's what the config class looks like. So for those of you who have never done Spring configuration using a Java class, this is primarily what it looks like, using @bean annotations to create your beans instead of XML configuration. We're kind of moving this way, except for when we use our Groovy scripted beans, and we stick out in the XML for that. So repositories. Repositories are the highest level right now, at least, of abstraction inside Spring Data. With repositories, you don't write any code beyond the interface, unless you customize a repository. So, but if you have a non-customized repository, then you just write a single interface, and Spring writes the implementation of that interface for you when Spring boots. It uses convention over configuration with regards to naming your methods, and I'll show you that in a minute. It hides, for the most part, the complexities of the Spring Data API as well as the Mongo Java API. You can still get down there to it if you want, because you can get the Mongo ops object. Once you have that, you can run them up if you like. It's typed, parameterized, via generics to the model objects you want to store. And you can create it basically two ways. You can extend a Mongo repository with your interface, or you can just use a repository definition annotation and say, hey, this interface is a repository definition.
Question, so the abstraction layer, does that help you swap out different types of NoSQL databases in the back end? Or can you go as far as say, okay, I'm gonna swap out my MongoDB with my own?
Well, you could. So keep in mind that your Mongo database is metadata mapped primarily to your data model objects, right? Your domain objects. So you'd have to go in there and swap. It's not as easy as you think. You have to go in there and swap out your annotations. It'd be, if you wanted to switch to say JPA, you'd have to go in there and swap out your annotations on your model objects. And then you'd have to go in underneath in the configuration and change from Mongo to a JPA implementation. So it's not quite that.
So the templates are just a quick start way to get
Yes.
there, not so much a need.
Repositories are, repositories are, once I've decided that I'm going to use JPA, or I've decided that I'm going to use Mongo, all right, and I've gone out there and I've modeled my application to the point of building my domain model objects, employee, customer, address, department, whatever. I can now take that and create a repository. So what really is a repository? To me, it is replacing the data access object. If I use Spring Data repositories, I never have a data access object. What I have is a repository sets between the model objects and the service objects. So those are my different layers of indirection right there. So the repository is basically linking my service calls down into my model objects.
So just a quick follow-up question to that. So not interoperability between relational databases and NoSQL databases, but can the NoSQL database specific annotations be used across different NoSQL databases?
So all I've used with Spring Data is Mongo.
Okay.
So I don't know.
I think those annotations are in the Mongo package,
Yeah,
so.
they are Mongo specific
We have
annotations.
stuff in the documents.
The document
That would be very
collection.
document database oriented, yeah.
Right.
So
but
let's say
the Mongo
couch,
dot
I don't know if they
document.
have a couch-based implementation, that would be another document-centric one, right?
Interesting. Okay.
But you still have to go underneath the covers and change out the Mongo template, Mongo operations objects.
Yeah.
Okay, so there wouldn't be, it's not that hard, but
And I'm guessing, like, from just a pure architecture standpoint, your application will probably need to be built to recognize the fact that you're dealing with like a relational database versus like a NoSQL database.
Maybe.
maybe, so I mean, to be honest, we've always built document-based applications and crammed them into relational databases, right?
Yeah.
And it's been easier for us in the last 5 to 10 years with, Hibernate, Spring, and JPA, and now with the annotations. That makes it a whole lot easier us to do annotated programming. So refactoring is easier than it used to be, but there's still refactoring.
I'm trying to remember, there's at least one, I think one of the JPA providers, OpenJPA, or somebody who actually wants to abstract, intends to like abstract across Mongo and other NoSQL or SQL, who cares kind of approaches.
That'd be interesting.
I can't remember which one it is, but if you go looking around, I remember writing across them. So like, hey, we're abstracting across all that. So presumably you could write JPA annotations to them, use them with Spring, and then the covers redirect them to Mongo and right there. But I haven't tried it.
Data nucleus.
What's that?
Data nucleus.
Thank you. Yes, also known as, it's been renamed, I think that is OpenJPA now, or something, it's the new name for it, right?
No, I think they're a standalone company.
Okay. Yeah.
Okay.
Naming habit there.
So we're talking about repositories right now. Here's some code for a repository. This is the employee repository. Again, this is my data access object there. I don't have data access object anymore. I have this. My service references this. Spring builds the implementation of this. And this implementation, once it's built, accesses my employee model objects, my address model objects, my department model objects. It uses, this particular implementation uses an at repository definition annotation to define that this is a repository that Spring needs to load. And then it uses convention over configuration. So right here, I'm getting a list of employees in my first call. My first method is to find list of employees back from find all. The idea behind Spring Data repositories is that the Spring Data folks have tried to, I guess at what conventions would be predominantly used in the industry. So find all is fairly, you can understand that easily, right? So, or the next one, find by last name. Again, that returns a list. You don't have to tell Spring how to implement this one. It knows how to do it. And how it knows how to do it is it looks at this class, this interface, and it looks at what's typing it. I'm typing this interface with the employee domain class. So then Spring looks at that employee domain class and it knows how to do that implementation based on this interface and that employee domain class that's linked to the Mongo database.
So when does I want to find all the employees whose salary is greater than 50,000?
So you can do that multiple ways. One way is to go down at the very bottom here and use an @query annotation. So the @query annotation, even though the repository itself is all about convention over configuration, the @query annotation says I can create a method called Fred and put an @query annotation in front of it, and then inside that @query annotation I would use Mongo specific query language, which is JavaScript, and have it go out and look for a particular document set that matches the query criteria that I'm trying to use. So I can create custom queries inside my repository, even though the repository is supposed to be used as a convention over configuration, high-level abstraction. I can certainly customize my queries if I need to. Okay?
How about find by support for pagination?
You would just change the query, the JavaScript to match that. Or you could perhaps use a custom repository that went into the lower level API and used a criteria and a query object that way.
So Spring doesn't support that.
I've not built one using the @query annotation here, but I have used custom repositories to add things to a repository that the repository layer doesn't support. So Spring does support it through custom repositories.
It's limits on the query.
Well, there are, yeah, so again, if you wanted more esoteric queries like that, then you would use a
I
criteria.
wouldn't call it esoteric.
No, you're saying top end, next, right, paging,
Yeah,
like you would in SQL, which would be top end.
Yeah, I mean, you can certainly do that with Mongo, but I would probably do it outside with a custom repository. I mean, convention over configuration, you only have but so many things you can do. Either you use the convention or you use the query annotation. If that syntax is not gonna work for you in the query annotation, then you were probably gonna write a custom repository. Okay, and I'll show you a custom repository here in a few minutes. Yes?
I guess is it fair to say though that, and this maybe can be generalized across all of Spring Data, that sort of the repository feature and the whole magic and convention over configuration and not having to write stuff, that's sort of just a small part of what Spring Data brings you, that you can use, like for MongoDB, you could use all these other features with Spring Data, with the annotations, with the templates, with the operations, and still get a heck of a lot out of Spring Data and Spring without having to go to repositories.
Yeah, I mean, to me, Spring Data is basically, while it's not a one-size-fits-all, it does have multiple layers in it that would help you do basically whatever you wanted to do. I mean, if you can hang out at the repository level, if you've got developers and your solution is such they can hang out there, your application development is going to be more streamlined, maybe a little quicker. And if your performance is supported using the repositories, then there's the trade-off that you make, right? However, if you need something that's more low-level or criteria-based, you may find yourself going either at the template level or below the template level into the Java API.
I hear repository, and I'm thinking Java content repository, JCR specs, so this is not actually modeling all the way to a full-fledged JCR.
No, this is basically, I don't know why they named it repository like that, but essentially this is a layer of abstraction right above the template that says, I understand that there's all this plumbing underneath, but all I need to know is, here's my domain object that I want to use, here's the interface I want to build. Spring, you go ahead and do what you think is the best plumbing for this implementation. And then I can give that repository, once I build it, I can give that repository to my service developers and let them service enable it with a service layer. So essentially what we have here, we have three different layers. I have my employee model object, I have my repository above that, and then I have my employee service above that. And so I'm just providing that to the different developers, and let them build, based on those contracts. So I'm basically setting a contract, obviously, with this interface and restricting them to do certain things. So when I talked earlier about rigor, this is where some of your rigor comes from. Your rigor can be implemented via this repository. If the service only uses a repository, you're only going to be able to do things that are in the repository. So, that's where some of your rigor comes into play.
Can you have both the repository and employee, and go down to the level you talked about?
Yes, you
earlier?
can. Yes, you can.
but somebody in a different application can define different repository that will store different objects in the same collection.
Yeah, it's quite possible.
That's where the
Because
rigor,
collections are not enforcing any kind of schema.
that's where your own rigor has to come.
Yeah. And that, yeah, I mean,
Or you don't allow other apps to hit this repository. I mean, the app is the conduit to the repository. It's a
Well,
repo. Dedicated-
Anybody can connect to the
step back to the
A
DBA.
dedicated server, is what I mean, a dedicated service.
So step back to the relational database administrator for a moment.
If you have one, yes, that makes sense.
Step back to the relational database administrator for a moment. I don't know about your database administrators, but I work with the Department of Veterans Affairs administrators. They can create diamonds from coal. So it's hard for me to get anything easily for my application team. So they control all this rigor for me. That's part of the adoption cycle that we're going through right now with them in Mongo. They understand that they don't have the tight control that they used to have. And so that's where the slowness for this adoption is coming. So what you understand now, the issue with, if I don't control who accesses the database, and what applications access the database, and what abstraction layers they use to access the database, then I don't control the rigor in that database. Because the rigor is no longer controlled at the database level.
If you want them to do,
Now, again, the
I tried to
database is,
avoid having it controlled over SQL too, but it doesn't.
again, the database is all based on BSON, it's stored BSON, and then a lot of your commands are JavaScript based, you know, dot this, dot that notation. So you could build a lot of different scripts to do things. Okay, it's just not where I'm at in this particular demo. Okay, so we understand the repository, right? The interface, Spring writes it, does the implementation for you. In my implementation, I have the services go at it. So let's take a look at the employee service real quick to give you an idea of how it's using it. I mean, it's employee service, simple. Really simple stuff there. I have a repository up here, and then I do a find all, and I just call the repository to do all that stuff for me. The same way that I'd call a data access object. That's why I don't use data access objects. To me at least, they're redundant if I have a repository. And the data access objects in the old days would be what we use to enforce access to the service layer, or to the data layer to begin with.
Was this generated, this one?
No, this one here I wrote. This is the service.
Is
The
there
repository gets generated.
is there an annotation or something at the top that actually tells it to use the
The employee service?
DAO?
No, the employee service, I'm just using old style Spring
Oh, okay.
setter injection.
Instead of injection. Okay.
I could, I guess I could use auto-wired or something
Yeah.
like that. But I'm an old fogey, I guess, I like to set slower, it never fails.
As long as it's not XML, man.
Right. Okay, let's see. Where we at now? So we've been through all that. The meta mapping. Again, the meta mapping is what ties, obviously, your objects, your domain model objects to the Mongo database, to the collections that are going to contain the documents that are underpinning your domain model objects. So again, earlier I showed you the employee one, right? So I've got employees, collection of these employee documents are going to be put into, again, like this gentleman said earlier, I could have a whole separate application that's using the employees collection and storing other things in there. Okay, again, your collection does not enforce the size, shape, or data types, or even column names. You know, collections just contain documents, there's not really an enforcement there.
Can you configure things so that sparse equals true as the default? You know, say everywhere?
I don't know. I mean, that's a good question. I've never,
Probably put it in the class level, but
Well, I mean, for the entire database, and for, at the MongoDB data level, so you don't have to go through this, you know, don't give me a bunch of blank stuff.
I would hope so, but I've never done it.
So what does person?
Person?
Down job.
Hojo.
Why did you put finding in person?
Well, I guess I could have. But I'm annotating the class employee, I'm not annotating the person. So I need to have the document annotation on the same class as the add ID. Okay.
Why?
So it just happens that the employee is a person.
Yeah, yeah. I think that's the natural behavior of that.
No corp to corp here, huh?
Okay, database references. So up until now, we primarily focused on embedding documents because we want atomicity and we want speed. However, if I wanted normalization, I would use database references. So database references, again, they're optional. I can use them instead of nesting documents. This is basically the closest thing you're going to get to normalization and joins. Okay. So what does that look like? I showed you this earlier as well, the customer object. Uses the customer's collection, and for address, I'm now not embedding, I'm using a database reference. Now the key here is that earlier, when I shoved 300,000 records into the database, I was using an employee repository. And what I had was a collection of employee documents, and I was calling save employee. And the repository was doing that for me. And it took the nested object of address and the nested object of department and just nested it into the document in the Mongo database. Here, I have to first create my data, my objects or my documents within Mongo that I'm going to be referencing so that I can use those reference IDs in the documents that are going to reference those IDs. So it's sort of a multi-phase save here as opposed to doing all at once and letting the API handle it.
So you have to create the customer address and save it, and then reference it,
Yeah.
reference its ID.
Yeah.
Is it always a eager fetch, where you can specify lazy fetch?
What was it? What?
The fetch mode, can you specify if it's eager or lazy?
You can specify that at the lower level API, yeah. Yeah. So here's what it looks like inside the database. So instead of having actual address data, what I have here down at the bottom is I have this key, and the value is this nested object here. And inside that object I have a $ref and a $ID. Obviously the $ID, that's the ID of the object that I am referencing. $ref is the collection that I'm referencing, this object within. So the customer address is in the customer addresses collection, and the ID that I'm referencing is right down there.
Are there like migration tools that do a lot of that work for you out there? I mean, you just have to have like code that's gonna insert the address, keep the reference, create the record, do the other thing. You just had smarter insert where it recognized these are similar addresses.
Well, there are scripted migration, there are scripted data loaders that are outside the Java API altogether that you can use if you're moving. I mean, these are based on, my 300,000 records that I pushed into Mongo were actually based on 6 or 7 flat data files. So if I had those data files already, then I could script Mongo using the Mongo shell and then load it probably a whole lot faster that way than I would be doing Java API.
Does Mongo provide you with like utilities to ease that transition to?
Mongo provides, 10gen I should say, provides you with, well, first off, 10gen will sell you the enterprise support, okay? 10gen, I believe, also provides the examples of how you would do that. I haven't been out there on the market to see if there's anybody that's doing sort of ETL for Mongo database, but to me, it would make sense that you could do that, but I don't know what the prerequisites would be or what the data files would have to look like to do that, yes.
Well, like earlier, when you were talking about your employees in the department, and the department could be a link. But let's say we have 2,000 employees in one department. You want to reuse that ID, and how do you, what does that look like in like the code you're putting there? You have to go find that department each time? Or is there some magic way that it knows what the department's ID should be?
Well, think about it, the employees, if I had the employee department as a database reference instead of an embedded document, the collection in no way, shape, or form dictates what references I would have to documents within that collection. So I would have to, within the Java API, know the ID that I wanted to reference within the employee document.
Right. So your higher level has to go find the department,
Yeah.
and then when that employee gets inserted, that ID is used.
Yeah.
If some properties are removed from data model after some time, let's say, what happens to those data available in the document? Those will be, those old properties will be stay forever, or it will flush those properties in updates or something like that?
I'm not aware of it removing any properties. I mean, you can set up
drop,
a,
you can drop in a column, what would happen to all the stored data?
there's no such thing as dropping a column. If I go into a document and I drop a column, I'm not really dropping a column, I'm dropping a field. All right, the column basically is a definition of a field with a cross reference of a document. right? When I go into a document and I basically delete a field, I'm only operating on that document. I am not touching anything else in that collection. Unless I touch the other documents, you know, but otherwise, no, I'm not.
So you'd have to iterate your collection of documents to drop the field out of the entire set.
Yeah.
Or use it-
But, on the flip side of that,
Probably do it back up in the higher level.
well, on the flip side, and again, you need to, I know it's hard to think about it ahead of time, but you need to think about these types of things as you're building your data model inside Mongo. Now, what I would say is that, you know, if you've ever done any kind of relational database modeling and then you put data into your schema and then you realize, oh crap, I need to change this column, or I need to delete this column, or I need to add a new column. Okay, adding a new column is not bad. Changing the data type of an existing column or deleting a column can get a little ugly depending on what kind of RI and cascades you've got turned on. You don't have that restriction in the Mongo documents.
You basically have to turn constraints off, change your data and go.
Exactly, and you don't have those constraints to turn off inside Mongo.
There are no constraints.
You have them inside the API, whatever constraints you put there. But again, that's only if you use that API. You can go around that API and do all sorts of nasties to your documents. Okay, please first.
You know, all this stuff that when people say, well, Mongo can't do this or that well, it reminds me that one of the great things about NoSQL is that you can have sort of heterogeneous data stores and use relational database for some things, a document database for other things, and mix it all together. And it kind of brings back the question I have. I vaguely recall that when you were domain objects, I think with Spring Data, you can map fields to, maybe some fields to something like MongoDB and other fields.
You
to
can do
some other
multiple data
source.
stores.
On a single domain object.
Yeah,
Okay,
I
yeah.
believe so, yeah. But as long as the annotations don't collide. Okay. Now, the one thing to keep in mind with regards to the documents that you're storing inside the Mongo database. So I'm using employee data model objects with an employee repository, and those are linked tightly to the Mongo database collection, right? However, as this gentleman has pointed out, I could mess with those employee documents all day long, not using that API stack, okay? So that brings out a particular concept that I don't normally talk about, and that is, in a relational database, we create views sometimes, which are just basically, you know, restrictive view into data sets. You know, maybe single tables, multiple joint tables, whatever. It's that view of that data set that we need. Well, the employee domain object, along with the employee repository, can be seen in the same light. It gives you a view and operations into documents within that collection within the context of employee as an abstraction. But I can go down there with any other lower level API and just start hammering on those documents and making a lot of different changes without going through that same abstraction. So, and maybe the changes I make will be seen through the employee abstraction, or maybe not. Maybe they are adding additional fields like, you know, tags fields, which are arrays of values that the employee model object doesn't even support.
I have a question that is pretty off the wall, but I've been using relational for about 40 years, and so my mind kind of works that way.
Just beginning.
How do I recognize as an architect when I should say to a group, you really ought to look at using Mongo for this type of problem? What is the deterministic kind of stuff that I should look for?
To me, because I started out, my first database was, well, my first relational database was Oracle, but before that, I worked with Lotus Notes in 1992, I think.
Oh, you children.
And you know what? I understand that. I don't have all the, in Lotus Notes or in other NoSQL, I don't have all the facets built into relational databases, right? However, I don't have the constraints either. So, in a Lotus Notes database, you had forms, and the user would fill out the document with a form. But again, that form is really just that focused interface or view into that document, all right? To me, it's a matter of what do I need to store and what type of constraints are the data going to have with regards to, you know, polymorphic data storage. So if I am going to have a document-based application, and I'm going to have the need to, at any given moment, make changes to or store additional fields without having to go through a data modeling exercise to get those additional fields stored, I would be looking at MongoDB. On the flip side of that, I'd also be looking at what kind of performance do I need to have, and what type of querying do I need to have, and is the querying such that I would really benefit from joined queries in a normalized fashion, then I may forego a document-centric database in lieu of a relational database.
But like if I was gonna have a store of images that customers wanna save into the cloud, and I want the customer to be able to get theirs back, and I want the customer to be able to name cohorts that they would like to be able to see them. You know, it sounds like that's the kind of thing that you might really look at Mongo.
Well, you can store files inside Mongo. You can store images inside Mongo database.
No, but I mean, but there could be some understanding about the customer, some cursory understanding about the customer, and cursory relationship between customers, and have their images attached to that understanding. Am I missing?
It's the type of data, I think is the point you're trying to make.
Yeah.
It really depends on the type of data that you're trying to store, and not everything needs to go into a relational database. And not everything, and there are some things you do want in a relational
Here's a
database.
Well, like
solution.
images are particularly nasty for a relational database.
So here's a solution. We're building forms for our customer, and we have a data durability requirement. Between screen transitions, we need to store data, right? So we fire off an asynchronous service call to store in-flight data. So if they shut down, or if they break down, or if we break down, their data is stored from the last save point we could possibly get, okay? You can imagine that it's a data capture exercise, form data. That screams document centricity. It just screams it. So that's a great solution to have Mongo underneath the covers. I can store those data as key value pairs for each field in the document, or I could just say, you know what, give me a bunch of XML and cram that into the Mongo database. So key in the value would be a bunch of XML. I can certainly do that, or base64 encoded XML if I wanted to make it more,
So you could use Mongo for the in-flight, and then when they get to the endpoint, and you need to add it to your collection of, 100 million.
You may have to submit to a relational database at the very end,
Right,
or
that's
you
what I
may make us, we
But
make
that, you've got all the
orchestration of several
flexibility
service
in Mongo
calls.
in terms of the intermediate form correlation.
I think,
Yeah, it's a great solution for in-flight data storage, data durability.
right, and also I think like some of the companies that are generating like huge amounts of data on a daily basis, Facebook, Twitter, and some of these other web tool companies, for them, I don't think relational databases I don't think they scale cost effectively to be able to handle it, and I don't think it even makes sense, right?
You can scale Mongo databases a whole lot faster, a whole lot less expensive. You can pull them out if you don't know, you no longer need 5 replicas in a cluster. You can pull one out a whole lot faster than you can with a relational database. With an Oracle RAC, if everyone's ever worked with Oracle RAC, it's not easy. Okay, Mongo is much easier to do that. To me, it's a matter of what kind of flexibility do you need with regards to storing your data? And does that flexibility trade off with any kind of performance concerns?
I can have quite a bit of flexibility of an in-flight, as long as it's just somebody typing into a scene. But once it's posted, there's zero flexibility, zero loss.
Well, yeah, we have the same needs. I mean, we have to, even if we submit our forms to a set of services in the back end that update a relational databases somewhere, we have to take a snapshot of what the user submitted at that point, and it lives in perpetuity, at least a year. I mean, maybe even 7 to 10 years, depending on when they finally get around to putting an aging on those documents. But again, we're just changing a flag in the database that says this is in flight, now this is persistent, and we're storing it in a persistent in-flight data store. So in that case, Mongo is fine for that, because I'm not reporting on those data either. It's a matter of, hey, this person said they submitted this at this date. Is there any kind of audit trail in it? Yeah, I'll show you what they submitted on that date. I'll show you what they submitted, I'll show you what we captured from the other remote systems and submitted along with their data, because that happens all the time, right? We make service calls out to get maybe PII or something, merge it with their data and then send it off down the road to the services that persisted. We need to have a snapshot of what they did. Now, we're not doing pure audit trails where we can tell what they changed at a point in time. We're not doing that. So in-flight data is saved, and the next time it's saved, it overwrites the previous in-flight save. We don't have the need for timescale audit trails.
So, I mean, it seems to me also the other major benefit in a NoSQL database that's based upon JSON is that it can be, you can throw anything. The address doesn't have to have 3 fields, 3 address lines. It can have 6 if it needs to have it.
You can do whatever you want.
Right, you can do absolutely anything you want. You're really only bound by the API, in this case, that has to access it. That's a view.
If you think about it this way, the document could be of any shape or size.
Right, so if
It
you
only
need
makes
something that
sense to
flexibility-
you, though, as an application user, if your API is built to pull those data and munge those data into something that the UI is going to use.
Right.
So,
Like an address, is a good example, because addresses all over the world are very different, right? So you may not want to have, a postal code and a zip code. You'll have whatever is necessary for the address that's appropriate for that person.
So just thinking about this idea about objects, being views and mutating data like that. So what would happen if you were using different objects? When you're storing the document, is there any point where if you're mutating an existing object where the fields are merged, or goes back to the point where you generate the document? You have your object, you're going to serialize those fields, or?
So it comes back to the write control that you have tuned into Mongo and what API level you're using. So for instance, I go in there and I store employee documents using the employee repository and the employee domain object. And then later on, I go out there and I want to touch those employee documents and update some field on there, or maybe add an audit.
Put an audit.
Put an audit, an audit field in there or something, and then perhaps at that point, once I have those audit fields in there that are not seen by the employee object at all, I perhaps have an interceptor in my API that munges those documents and changes those audit fields, right? Again, the issue you're going to run into is more or less controlled at the very low level Mongo layer, as far as write control over those documents. So I don't know all the tuning aspects that you would have to have in place to make sure that you didn't step on, but it would be similar to optimistic locking type algorithms that you would use in a relational database. So.
Well, at the document ID level, when you save a document, it's just going to write over whatever representation.
Well, you don't want to write over the document ID, if you can help that. You don't want to do that. But
Well,
the reason you don't want to do that is
That's
because
different than writing over a document at that ID.
No, that's what I was saying. You see, obviously you can't change the amount, you can't change the ID.
yeah, you don't want to change. You can, if I go out and create an employee object, I don't explicitly say, here's the ID.
No, I can't.
However, I could go in there and change that, I think I can go in there and change that ID with a low-level API call. Of course, if that object's loaded in the API somewhere else, I've just hosed somebody or myself.
No, I was talking about changing an object, right? You're going to change the contents of that document. And I was just trying to get this idea, what you're talking about, this view idea, whether it made, you could have transparent fields, multiple views, and we're not going to step on each other. You're saying you do that or you don't do that.
Well, I mean, at that particular aspect, it's almost, to me, it's almost the same as if you had a relational database. You have an algorithm in a relational database to set up optimistic locking, for the types of munging that you're doing on an individual field-by-field basis in a row. So,
I think it's more a question of how SpringData works. If it does.
well, we're talking about going below SpringData too. I mean, my example was going SpringData to load the document and then maybe going outside of SpringData to use, an aspect-oriented approach to updating audit trails within the document that the Spring Data repository would not even pay attention to. So, I mean, I don't know exactly how you would tune it or what settings you have to enforce. But the overall, you'd be reaching for what I would liken it to optimistic locking. You know? That's what you'd be trying to reach for. So that type of right control that you won't step over somebody. So,
Not indicated with the shape of the object. In collide.
you have to give up a few things. At the end of the day, if your document shapes are different than what you think they are, does it really matter? As long as you're getting the correct data in the shape that you need. So if I go out there and I have 50 fields in the employee document, but I only really need 20 of them, as long as the data within those 20 fields are correct, do I really care what's in the other 30 fields?
Right, and that was,
Well,
the scenario I was talking about. If I change so I've got my Spring Data model object and it sees those 20 fields, I change them. What happens to the other 30 fields that I don't see? Can I change those fields and they're gonna remain the same in that object?
Yeah, they're individual field by field basis. I mean, you're not, the question we had earlier, is it going to modify the document itself? Through the low-level API, you can basically use updates to just attack or mutate those fields and not mess with the entire document. So if you had a need to do that, I would basically isolate your needs to system-level work through perhaps a lower-level Java API, and then business layer work through the repository abstraction.
But let's say we have a collection, okay, among an embedded thing.
Constantine, I'm sorry if I may interrupt. We're running very close to the end time, so maybe over drinks.
I've only got about 60 more slides to go. We're almost done. And I'll hang around later, and you guys can stump the dummy more later on. So custom repositories. So you guys, this is right up your alley because 5 minutes? Okay. This is right up your alley because you guys want to take it beyond what the repository will do. So for instance, if I needed to do things, custom queries that I couldn't do through a query annotation or convention, I would go to custom repository. So you know what a repository is. It's just an interface that Spring writes the implementation for you. A custom repository basically is you write another interface, and then you write an implementation for that interface. And then what happens is you link them together so that as Spring is implementing your repository interface, the implementation of your custom interface is being interleaved with that implementation. So the end result is a repository that has not only the conventional things that Spring wrote for you, but the custom things that you put in there as well. So for instance, here's what it looks like in a graph here. Spring Data repository interface down here. My custom interface up here, okay? I write a custom interface implementation. Then we have the application and repository interface here. Spring boots up, puts them together. The end result is the implementation that has both my customized methods as well as what Spring wrote for me.
So you have to come up with different names for those methods, so there's no conflict between, you can't have find all, they have to find all?
Yeah, I mean, you're gonna have a collision there.
All right.
And Spring's, it'll puke just like it does when you can't find a bean. We ran out of time, so I couldn't show you some of the advanced queries, but you can do queries with, where field values are in or not in or greater than, or you're looking for all of these field values. There's tests out there to do that. MongoDB has different aggregation functions. It has its own aggregation framework. You have a map reduce set of algorithms. You can also do distinct. You can do group, which is similar to group by, but you have to write some JavaScript in there, JavaScript functions. Just ran out of time. GridFS is a file system. You can store files inside the Mongo database. Again, you have 16 megabyte size documents, but all that means is that if you store in a very large document, Mongo is gonna chug along and chunk those things up until it gets them into enough documents to store your file. So what that looks like is if I stored a 10 gig file, how many 16 megabyte chunks is that? Okay, if I'm storing a 10 gig file, that's not a solution that I would like to put in Mongo database unless I had very fast network and very fast Mongo nodes, because it has to chunk through a lot of chunks to build 10 gigs for a file. Indexes, similar to relational indexes, can have many, can be compound. Makes your write slower, so be careful. There's a trade-off there. Sparse equals true. I don't know if you can set it up against the entire database. Here's what an index looks like inside MongoVIEW. Security, I'm just touching on this. You can use some switches there to use authorization, or you can use key files. I guess if I were going to connect applications, if I could get away with using auth, I would. But if not, you know, if I had an encrypted network, I would. If not, I'd use key file. Encryption, Mongo doesn't really support database encryption per se, but you can use other things like Gazang to use, you know, if you want to use transparent data encryption, which is a field-by-field encryption type. Mongo licensing, I'm not going to explain what they are, but they are different enough that you really need to pay attention to these.
Mongo wouldn't be cognizant of it, but Mongo wouldn't care if the content.
Mongo wouldn't care.
on the-
You can look at it multiple ways. Mongo should not care what you're storing in there. So if you encrypt something, it's primarily going to be API-based encryption. The reason why I bring it up is because Oracle has Oracle-based transparent data encryption. Okay. And hardware-based keys that, you know, so that people can't, you know, discover your keys. 2.2 is out. I'm not using it here, but it's supposed to be a drop-in replacement. It can do aggregation now without MapReduce. It has TTL collections. I talked earlier about capped collections that rotate like a rotating log. TTL collections are time-to-live collections. You set up a time to live and the document just disappears, you know, evaporates. Sort of like if you needed to age your documents out of a collection. If you had some type of document control algorithm where a document's more than a year old needed to disappear, there you go, time to live. Tag-aware sharding. Tags are basically an array of values that you can add to a document. So, like for instance, if I'm using Mongo as a backend for my blog, I could use tags against that blog entry. I could have multiple tags in that tag array, and then I could shard against those tags if I wanted to.
So each shard would contain anything that was tagged.
Depending on how you set your shards up. Remember, divisibility is key, all right? So
But if you have,
I
if
don't-
you have a blog entry with 4 tags, it would be in 4 shards.
if those 4 tags were in 4 shards.
Oh,
Your
okay.
sharding could be such that all 4 of those tags are in the same. It really depends on how your sharding's set up. Okay. No questions. Because I think you guys are exhausted